Okay. Okay, great. All right. Thank you for coming. Yeah, very warm welcome here for you guys already attending the webinar. So today we'll be talking about the FreeBSD, FreeBSD OS. My name is Achmad Mardiansyah, and then I'm from JLS Networks. So here are our agenda. We'll be talking about the introduction first, and then review some prerequisite knowledge. Okay. And then some FreeBSD basic running services. Perhaps we can do live practice if time permits. Okay, so introduction. So first, for those who are new to JLS Networks, we are JLS Networks. JLC Garden stands for Garden Universitas Cakrawala. We're based in Bandung. Our areas are IT and IT consulting and training, video microtik, ubiquity, Linux Foundation, Linux, sorry. Yeah, yeah. We have a cooperation with the Linux Foundation. Products is Radius Manager, and then our regular event is done every week. My name is Mardiansyah, and I'm based in Bandung. I'm Linux user, microtik user, many users. I'm programmer as well, doing programming for living. I wrote some articles in some websites, and then I have LinkedIn account. So if you have LinkedIn account, then you can connect there. Okay. Past experience, mostly related to networking and then system integration. So we are not only migrating, for example, from bridge network to routed network. We are not doing the OSPF, BGP, routing filter, and so on and so forth, but we also do server installation, Linux maintenance, and so on and so forth, including FreeBSD. Yeah, so the FreeBSD that I'm talking about here is some sharing experience in our past project. About the webinar itself, we start from in 2010, a long time ago. Yeah, at the time we were talking about the Solaris operating system. And then, yeah, thanks. That's for me. And then for you, can you please share some of where you are from? Okay. So at least we know where you are. So usually there are people from Europe and Africa and some part of India or Pakistan or Nepal. Some are from Asia, like Philippines or Malaysia. Okay, so please don't shy, just introduce yourself here in the group chat. Yeah, really appreciate that. Okay. So prerequisite, we assume you already know Unix, okay, and then have some experience with that, okay. Able to operate Linux, so at least you know some commands. Yeah. Okay, so let's do review. So we know that we always, when you open a computer, so in that computer, there must be an operating system. So operating system is the software. So we have three layers for computer system, right? So we have a hardware, things that you can see. Inside the hardware, we have the OS, okay. It's a software, sorry. Hardware, inside the hardware, we have software. And then inside the software, we have operating system, we have application, and then we have brainware, is the person who operates those things. Okay, so operating system is part of software, which is installed inside the hardware. Okay, so if we take a look more, and then inside the operating system there is a kernel, and then there is an application, and then if we zoom the operating system, we can see there is a core component named kernel. Okay, so kernel is the software. But how the software looks like? Does it look like Microsoft Windows or like Microsoft Excel? Well, not both of them, okay? Because there is no visual interface for the kernel, but the kernel is still there. Okay, so the purpose for the kernel is very crucial. Yeah. So kernel here is the core operating system, and then here are the hardware. Okay. So kernel is the person, not the person, is the component that connects to the devices directly. Okay. So that's why it has a vital function for operating system. Some functions like hardware access, so this one you need drivers. Okay, so that's why when you have a new hardware and then that the hardware is not recognizable by operating system, it means that it requires a software so that it can be used by operating system. And then for that one, you need to install driver. In Windows, we call it driver. In Unix, we usually call it modules. And then kernel also responsible for executions like multitasking, like you are typing in your browser while listening MP3. I don't know whether it's still MP3 or not. Usually people do streaming these days, right? You just subscribe Spotify or YouTube Music or whatever. Yeah. But in my age, usually we collect those MP3. Okay. So next is, for example, interrupt. Okay. So for example, you are sending, you're doing chatting through while watching a video, for example. So that activity is possible because you have an interrupt. Okay. So when the packets arrive, and then there is an interrupt from the network driver to the operating system. Please hold a moment. So can you please allow me to receive those packets? So that was interrupt, and then doing memory management, disk access, and file system, networking, security, many stuff that was done by the kernel. But yeah, the thing is, the kernel is there, but with no visual. Usually the kernel is programmed based on CPU architecture. So we have several operating system here, okay, including FreeBSD, and then here's their kernel name, Solus kernel, FreeBSD kernel, and then each kernel is compiled according to CPU architecture, like x86. So this is x86 64 means 64-bit. PPC means Power PC. Spark means it's a Spark hardware. Previously was manufactured by Sun Microsystem, and many others. Okay, so all of them currently already support multitasking. Yeah, but previously it's not. I use Windows MS-DOS at the time. So if you want to learn, if you want to do something, you have to be focusing on that. So you cannot do like you're doing games while listening MP3 while doing your Excel sheet. At that time, it's not possible. So because it is based on disk, okay, so you have to put your disk and then load the software into the memory, and then you do you're doing your application, and after that you switch to other application. So it's not multitasking. Yeah, a long time ago in 1990s. Yeah, so yeah, as I said, how the kernel looks like. Well, if you download the FreeBSD kernel, and then usually the kernel is saved, stored in this directory. Okay, USR SRC system, and then there will be a folder for architecture. Okay, and then here's the C programming code. Okay, and then here are the code. Okay, so this is how the kernel looks like. Okay, but looks scary. Yeah, that's the code. And then after that, the code is compiled and then becomes a binary. Okay, so binary kernel. And then usually we put the binary kernel in some folder. In Windows, there is an NT kernel, but I don't know where there is. Maybe some of you knows. I'm not Windows person, so I use Windows. Yes, I used Windows last time as my main operating system in 2007. After that, I switched to Linux, and then yeah, because I have Mac, and then the main operating system is the Mac. So if you are using Linux or Ubuntu, so this your kernel will be named like this. It's a kernel, yes. If you are using Solaris, the Solaris kernel will be put here, Mac OS, and then FreeBSD kernel, so in this directory. So the location of binary kernel, it depends on the vendor. It means the things or the organization that builds the kernel, that compile the kernel. So it's up to you. You can put the kernel wherever you like. And then as a standard, we have partitioning. Okay, so when we have an operating system, usually we do partition. Okay, so we have a big disk like this. Okay, so this disk is very big, up to 232 gigabyte. So we don't use all of them, so that's why we do partitioning. Okay, so with the partitioning scheme, that depends. Usually we do DOS partitioning system. And the big drawback for this DOS operating DOS scheme is a maximum of the partition is 2 terabytes. Yeah, I had a bad experience with this. Yeah, so yeah, in one of our projects, so I installed a big hard disk. The capacity of the hard disk is 10 terabyte. 10 terabyte. 10 terabyte. Okay, I choose DOS, and then when I increase the partitions, it stopped at 2 terabytes. Okay, so I have to change. So I have to move the data to other partition and then recreate the partition. Yeah, it was a bad experience. So if possible, you can use GPT. Okay, forgot the abbreviations, what the GPT stands for. But if you have an option, so just choose this GPT. Let's say you are using DOS, and then in DOS partition, usually for primary, you have maximum of 4. Yeah. So for example, this is DOS. So maximum partition you have is 1, 2, 3, and 4. The blue one here is considered one big partition. Okay, and then inside this partition, you have a sub-partition. Okay, so this one is called usually SDA1. This is SDA2, this one SDA3, and then this blue is called SDA4, aka extended. And then inside the extended file system, you have SDA5 and 6 and 7 and yeah, I forgot how many maximum subpartition you can do. Okay, so that was partition. In operating system, they have different naming for that concept. Okay, so this is, for example, we have an operating system of Solaris, Mac OS, or Windows, FreeBSD, or Linux. And then for the primary partition, if you are using DOS, it's called partition. And then for the subpartition, So partition inside the physical partition is called slides. Okay. So S1, S2, S3. So that's how they do naming usually. Yeah, for Windows, usually you have a primary partition, and then for the subpartition in the extended, we call it extended partition. Okay, in FreeBSD, we call it slice, and then subpartition is called label. Okay, in Linux, we call it primary partition, and then subpartition logical or extended partition. Okay, so this one is if you are using DOS. Okay, so DOS, we assume you are using DOS. Okay, if you are using GPT, it's different. Okay, so what else the difference about directory structure? So in Windows, it's explicitly the Windows system shows you the partition. So if you see C colon slash like this, it means that, oh, okay, so these things, this object is located at the C partition. Okay. And then you have another partition like D, E, F. So the naming is start with letters. Okay, letter C. Why not start A and B? A is floppy, B is floppy. C is the hard disk. So that's the I mean, you can trace the origin from the MS-DOS long time ago. Yeah. So with MS-DOS, you have floppy, two floppy usually, floppy A, floppy B. Yeah. So that's why it's called drive A, drive B. And then if you have hard disk, it's called drive C. With Unix, it's different. Okay, or Unix-like. Okay. So Unix and Unix system, they already have a complete structure. That is called FHS, file hierarchy structure, a file hierarchy standard. So there it's defined, okay, for example, if you are using root, if you are root user, and then this is your directory. And then there is a directory called etc, USR, USR lib, home, and so on and so forth. So we cannot see directly on which partition does the data is stored. Okay, so unlike Windows here, we see explicitly that okay, it's saved in C. Yeah, so there must be a partition for C. So in Unix, it's not like that. So that's why it's more simple, in my opinion, and it's unified because you don't have to remember is it C or D or E. Nothing is more organized, and then it allows system to use a shared library. And then if you use shared library, it can lead to a dependency problem. So you have to install software A, but before you install software A, you have to install B. Yeah, so that one is called dependency problem. Next is about the file system. So previously we already have a partition. Okay. After the partition, then we set up a file system. So file system is a software or a method data structure provided by operating system to control and manage how the data is stored or retrieved. So, so when we talk about operating system, everything in software is about file, correct? Your MP3 files, your movie files, your Microsoft Word files, your text files. So everything is a file. Yeah, so operating system is just a bunch of files. Okay. So logically, there must be a way to manage the file. So that's why it's called file system. Okay. Yeah, so this is some types of file system. Okay, so it can be disk-based, like FAT. When you are using a USB drive, yeah, you usually use this file system. NTFS for Windows, extended for Linux, extended 2, 3, and 4. UFS is for Unix, UFS Unix file system. Yeah. And then etc. You have a universal disk file system. Yeah, this is for CD-ROM. And then you have also tape-based database file system. For example, Oracle, they have their own file system, so that when you install Oracle, Oracle just need, okay, I want to have a special partition, and then inside the partition, I have my own file system. So, and then we have a network file system, and then other file system for cluster. Okay, it's like the one, like a Red Hat cluster, yeah, and other cluster as well. Also, the type of file system can be divided into journaling and then non-journaling. The journaling means every time you do operation on files, you have to make journal. You have to write, okay, I did writing these files at this time. Okay, so it's like a normal journal. So everything you do, you write them down. Okay, so this activity, this journal, is very important when you have a file system corruption. Why? Because you can see the last log. Okay, so on which files, which last file you did the operation, the IO operation. Okay, so that one is good. But some file system, they don't need journaling. It's like the ZFS. Yeah, they don't need journaling. We will discuss the ZFS later. And the way ZFS works, already discussed in a previous webinar as well. Okay, let's talk about Unix. Yeah, so previously we already discussed the concept of operating system. Okay, where the operating system requires some has some features like accessing, mostly for accessing hardware and then managing processes. Okay, and so on and so forth. Okay, so let's talk about Unix. So previously, we know that there are many operating systems, okay, and one of them is Unix. So this is Unix history. Wow, quite big, eh? Okay, let's change the color. Okay, very purple. Yeah. So the Unix started in 1970s. Okay, Unix from AT&T and United States, yeah. And then they built Unix, okay, and then they keep doing it until in 70s, okay. So they share the source code. At the time, AT&T is not allowed to sell software to the public. So okay, I have software, and then I have the source code. Okay, well, perhaps you can. If you want, then you can modify. Yes, then you can modify. So it's called the modification of the Unix is called BSD, Berkeley Software Distribution. So from Berkeley University. So Berkeley. So only one university that was improving the original Unix. No, it's not. There are many universities, but the BSD is the central for those changes. So we can say BSD is like a GitHub in recent days. So it's like a clearinghouse. It's the centralized place for putting those changes. At that time, we don't have GitHub. We don't have version control. We don't have that kind of stuff. Okay, so we need to have a centralized place for storing the what is it, the changes. Okay, so the process is keep going. Okay, BSD.2, BSD 4.3. Okay, so and then we have problem here. Okay, start from here as well. Yeah. Basically, the government said, okay, AT&T, you can sell software now. Okay, and then what happened? And then the AT&T charged. Okay, okay, you can have my code, source code, but you have to pay the price. Okay, no problem. I'll buy that. Okay, so that's why from the Unix, it become the Sun OS, Sun operating system, and then from the Unix it becomes Xenix, SEO, it becomes AIX. So this is from IBM. IBM buys the both IBM bought the source codes and then they create their own Unix. Okay, Xenix, I think Siemens, Siemens Germany. Yeah, Siemens also Xenix. Yeah, they develop, I think they develop their own Unix. And then Microsoft also doing Xenix here. But yeah, it seems that they created a new operating system, which is DOS. So yeah, they don't use Xenix anymore. Okay. So and then we have problem here. Okay. And then they charge to BSD. Okay, you have to pay now, but they Berkeley said that, but we already done many improvements to your operating system. Why do you have to pay? But this is our code, okay? And then they are battling in the court, and then settled around here, yeah, in 90s, around 90s, around here. Okay, so the BSD community replace all source code from the Unix. Okay, and then after that, it becomes the BSD 4.3, 4.4, and then up to BSD what that we are using now. Okay, if you see Mac OS, okay, Mac OS has a root from BSD. Okay, what about Linux? Linux is written from scratch. There is no code from Unix in a Linux kernel. Okay, so this is Linux path, and then this is Minix, and then all of them here are proprietary Unix. So the green one here is open source. The red one here is closed source. You cannot see the source code. Okay, except Solaris, and then become Open Solaris. Yeah. So today we are talking about the BSD. Okay, so that's the history of Unix. Okay, so let's continue. So the Unix itself actually is a trademark. It's a brand, and it's a standard of operating system. And because you have standard, and then there is an opportunity to have a certification for operating system. Okay, and then Unix is managed by the open group over here. Okay, so this is their website. And then what they are doing is to certify operating system. So if you build an operating system and then you want to state that, okay, my operating system is Unix. So you have to go to open group. Hello, open group. This is my operating system. Please certify. And then you have to pay an amount of money for them. They will do their job, blah, 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 blah. And then they will give you, oh, okay, you are Unix now. So if you see, here are the Unix operating system, okay, including Apple. You have Apple, IBM, HP, Huawei, IBM, SEO. Okay, so those are Unix operating system. Okay, so what about Unix-like? Well, Unix-like means it behaves like a Unix OS, but not certified by open group, so no certification. Yeah, so for example, is BSD and Linux and then Minix and then other stuff like that. Okay. So again, Unix is just certification. Yeah, certification is important if you are in the business. It means that it's a proof of you already achieved something. Okay. Yeah, of course, for that you have to pay an amount of money. Okay, so that was the Unix. Let's talk about the FreeBSD. So FreeBSD, as I said, it's come along from the Unix root, okay, from 1970s up to now. Okay, so some codes are still there, yeah, from a long time ago. FreeBSD has license. It is the most liberal. In Linux, we call it GP. There is a license called GPL. In GPL, if you want to modify, you have to provide source code, okay, for GPL. And then with BSD, it's much more much more liberal. You don't have to provide open source. You don't have to provide the source code, okay? So if you take FreeBSD and then you say, okay, this is my operating system, FreeBSD do not care. Okay, so that's the BSD license. It's very, 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 I can say, and some people, is it stupid? Or maybe not, okay? So you can claim that BSD operating system is your operating system, and then they don't care. And then nobody will sue you because of you are doing that. Okay. So don't claim. So if it is break, don't blame. Yeah, don't use our name. Okay. So you just take, do whatever you like, and then it's up to you. Okay. GPL is more strict. If you take a GPL code and then you do modification, you have to provide the source code of your modification. So yeah. So what's the benefit of BSD license? It's easy to adopt new technology. Yeah, because sometimes, not sometimes, often people are afraid, oh, okay, what happened if somebody sue me because I'm doing this, right? Well, with BSD, no problem. You can do whatever you like. Okay, so that's why FreeBSD is very easy to adopt new technology like ZFS and then dtrace from the Solaris operating system. And then it's easy to port other operating systems like Juniper, Cisco, PlayStation. Okay, PlayStation is also use BSD, and many other systems. Okay. Yeah, about the development process. So FreeBSD as when we talk about FreeBSD development, means that the programmer, well, it's less buzzer and democratic, so there is no single figure because FreeBSD is managed. The development is managed by team. Okay, it's not managed by single person like Linux. So Linux, you have Linus Torvalds, right? Linus Torvalds. So this is the one that is that is controlling the Linux source code. Linus. Yeah, Linus Torvalds. So he is the one that decides, okay, I like this, I don't like this. Only one person. What happened if he is sick? I don't know. Yeah, maybe there is a team as well for Linux. But for FreeBSD, the development process is like this. You have a core team, like 10 people, 10 to 12 people. Yeah. This is for management. And then you have committers. Okay. Similar to Git. So when you are using Git, there is a permission where you can clone the Git, but you cannot make modification on that Git, right? So if you can make modification, you have to do commit, like a Git commit -m blah blah blah. Put your comments there, and then you submit your update, your changes. Okay. Yeah, so because they can do commit, it's called committers. And then they have we have contributors. Yeah, they just contribute, but doesn't mean that it's always guaranteed that their patches, their updates is received is approved by the committers. Okay, and then we have users, which is us. Okay, so that was the BSD development process. Moving on, FreeBSD is just one of the BSD variant. Other BSDs like NetBSD for portability, OpenBSD for security. Some ISP also use this one. Okay, because many software, many routing software are networking software are from this OpenBSDs like SSH, right? SSH, OpenSSH, right? SSL library, yeah, like OpenSSL, it's from OpenBSD. Now they use Libre SSL. Okay, that's from OpenBSD as well. We have macOS, desktop BSD or PC BSD, many BSD. But compared to Linux, the variation of BSD is less compared to Linux. Not so many distribution in FreeBSD. And about FreeBSD itself, why we choose FreeBSD? Well, because it's free, open source, BSD license, it's stable, okay, high load. In high load, okay, portability, it supports many architecture. Yeah, because I remember at the time, I have one very old machine from Sun Microsystem, and then the software itself is not available. So I'm using the FreeBSD for trying to install something in the Spark hardware. Okay, hardware range, yeah, it supports from old to new. Package management, yes, we have package management in FreeBSD, like apt-get, aptitude-get, aptitude install, like yum or DNF in CentOS, or if you are using SUSE, no, I forgot. Yes, yeah. So it's easy to upgrade as well. Good documentation, and that is got advanced features. Yeah, like ZFS, UFS, dtrace, SMP, high-speed interface, HTTP, BSM, and then many software. Okay, yeah, this is, for example, high loads. Okay, I have experience also this one. Yeah, so this is the load average for, I think this is 1 minute. This is 5 minutes, and this one is 15 minutes. Okay. So in 15 minutes, we have 407.19 load index. Okay, yeah, which is quite high because the core, the CPU core is only one. So this one is is very high. And then the source cause is from this one. So it's 93% is from user. So there is a calculation happening on FreeBSD. Yeah, usually if there is a high I/O, then there must be a high I/O over there. Okay, so this is even though we have a high load, but the system is still be able to respond. We still be able to log into that machine, even though the load is very high. Yeah, so what you can do with FreeBSD, you can set up many things like FreeBSD web server, email service, okay, router, yes, router. But I don't see a vendor that is based on FreeBSD. Yeah, I use MikroTik, and then MikroTik is using Linux kernel, not FreeBSD. Okay, but other platform like Juniper, they are based on FreeBSD, of course, with their own modification, like ISP routers. Okay, some ISP using FreeBSD or OpenBSD. A firewall as well. For example, this one is PF Sense or OpenSend. Okay. Then we have FTP, DNS, database, so on and so forth. So many usage for BSD. Then, yeah, if you install BSD, as I said, BSD, unlike Linux, when you say Linux is just a kernel. Linux kernel. Okay, so Linux kernel is one thing, is one software. And then this software, this kernel, needs to be bundled with other stuff like Apache or Bash or other software, right? Like MySQL, MySQL. Sorry, my handwriting is not good. Yeah. So you bundle this software, and then it becomes distribution or distro. Okay. FreeBSD, you have a base system. Okay, so base system includes kernel, and then some userland packages like libc, OpenSSH. See, OpenSSH is part of base system. So you have a base system, you have an external system like a third party, SSL, etc., etc. Okay, so therefore, if they already include, so all of them is part of FreeBSD core system. Yeah. So unlike Linux, so when you talk Linux is just a kernel. Okay. And then with the kernel, what can you do? Nothing, right? Just a kernel. Yeah. So that's why if your operating system wants to make a benefit to others, you need to add more software to accompany the kernel. Okay. So because the kernel itself is useless. Okay. Okay. You already load the kernel, and then so what? You cannot do ls, you cannot execute a Firefox to open the browser. There is no browser, there is no any other software like Microsoft Word or a gaming. Yeah, because you only have a kernel. No. Kernel itself is not enough. Yes, it is core operating system, but it's not enough. We cannot work if what we have is just a kernel. So we need to have an application. There's some application already put into base system. Yeah. Okay. So yeah, FreeBSD is, I can say it's a complete operating system. Okay. Next thing that we need to know about FreeBSD is how they release their software. Okay. So here we have a base system. Okay. Previously, in the previous slide, we know FreeBSD has a base system. Okay. And then currently it's under yeah, this one is a long time ago, but now they changed to SVN, from CPS to SVN, and from SVN, I don't know they use it or not. I don't remember. Okay. So when you install FreeBSD, so make sure that you're installing from the release. Okay. So first, start means start with current. So currently is FreeBSD 13, right? So in the future there will be FreeBSD 14. So 14, so there will be a current branch. This one is not stable. People are doing here and there. Yes, it's not recommended for production. Okay, after they do testing on current, and then the code will become stable. Okay, and after stable, it will be over here release. Okay, so what you install is the FreeBSD release, not FreeBSD stable. Even though the name is stable, no, it's not. Okay, stable, but still on development. Okay, okay, so that was it. FreeBSD features, we already discussed this. And then this is one example of FreeBSD ZFS. Yeah, so ZFS do not need to use journaling. So for example, we have an overblock here. And then if we want to make a modification on a particular file, for example, this is the original data, this is new data. Okay, so the new data will be written in different blocks. Okay, so that's why you have a, we call it copy on write. Okay, so you have a file and then you want to modify the files. So your modification usually it's verbally replacing the blocks. Okay. Yeah. So with the current file system, you're just replace the blocks that is used by the current file. With ZFS, it's not like that. So if you modify, and then the ZFS will create a free block where you can put the new data on it. Okay, so after it's successful, and then we will change the pointer from the old address to the new address. Okay, so that way, if something happens, okay, and then we don't have problem. Why? Because if there is a happen when we try to connect, the original data is still there, and still valid. Okay, because we don't replace the block. We are looking at new blocks to store data. So that's I think that's the very good trick of ZFS. Okay, so this is original data, this is new data. They are not being replaced. Okay, and then we update the pointers. Okay, so here update the pointers, and then here we go. So this is our new file. Okay, yeah. Yeah, in the future, we have planned to have ZFS, what is it? ZFS demo. Yeah, we discussed ZFS, but due to time, we have to stop. Okay, some untrue myths. FreeBSD requires a lot of things, but actually it's not. Yeah, but yeah, some drawbacks from BSD is like vendor support. Yeah, lack of support here. Yeah, it's true. For example, for the hardware. So, for example, Dell or Ubuntu, not Ubuntu, or HP. Yeah, they don't bundle their hardware with FreeBSD, right? Yeah, yeah. Some aspect here are true. Are difficult to learn? I don't think so. As long as you have a good understanding about how Unix work, you are okay. Software availability, that depends. Yeah, but if you are using like a software like SAP or Oracle, there is no FreeBSD portion for that. So yeah, next. Yeah, so let's do live practice. I have prepared a software here. You can use it to display how you install the FreeBSD from zero. Okay, I'm preparing the CD-ROM. Yeah, installing FreeBSD actually is not that hard. Okay, let me share. Okay, so I'm using an emulator here. There, you can see. Okay, let's start the installation. Yeah, so this is I'm booting from the ISO file. So in the real situation, perhaps you can burn the ISO files and then burn the ISO files to USB drive. Yeah. Welcome to FreeBSD. Would you like to begin installation? Yes. Yeah, we can just use installation. Okay, and then here we are asked to choose the we are asked to oops. Yeah, we are asked to choose the keyboard. Okay. So here I'm continuing with the default keyboard. Okay, so and then here we put the name, template, FreeBSD. Okay, that's the name. So, and then here's the distribution. You select. We have a kernel debugging. We can install ports and source. Yeah, and then click OK. And then here we have file system. Okay, so we have two options. Either you are using ZFS or UFS. But this one, yeah, ZFS is very good file system. But in order to use it to use its full potential, you need to have a RAM. Okay, lots of RAM. To use ZFS with less, it's recommended to have minimum 8 gigabytes. Yeah. Otherwise, you can use others file system. In this case, in this installation, I choose UFS. Okay, so here you can see on my system there are two disks. Why the name is different? In Linux, we have SDA, SDB, SDC. No, it's not. In FreeBSD, no, it's not the case in FreeBSD because in FreeBSD everything is based on the driver. Okay. So here, if the driver for that detects the disks is VTB. Okay, it's VTB. It's a virtual virtual block. Yeah, VTB means virtual block. D0 means D0, means the first hard disk, and the capacity is 13 gigabyte. And then we have a second disk here, so two disks. Okay, two hard disks, and then we will install the main system on the first hard disk. Okay, we choose entire disk. Are you sure? Yes. This is what I said. It's recommended if you use GPT, yeah, because yeah, it can support big partitions. Yeah, if you choose DOS, and then there are many limitations. Okay, so you can use GPT, and then because you already use automatic, So this is the automatic things that FreeBSD do for you. So usually they will create 3 partitions. So you can see P1, P2, P3 over there. Okay. Yeah, so this is the first hard disk, and here's the second hard disk. Okay, so both of them are using GPT. Okay, so this is partition 1, partition 2, partition 3. Yeah, so this one, and this one. So here's the capacity. Okay, so I think I need to adjust the FreeBSD swap. For example, this is just example, and then we can delete this one over here, right? So this is for delete, for create, modify, revert, auto, and finish. Okay, so we can just delete that one. Yes, also delete. Then we can recreate the partition. No, oh, okay. Yeah, so we go to the first hard disk and then press tab, then create. Okay, FreeBSD UFS. Okay, press tab to move, and then I will allocate this just for 11 gigabyte. Mounting point is slash, and then the labels, well, you can put it or not, it doesn't matter. I put here label root, for example, and then for options, I activate the trim for SSD to freeing the if a block is not used. Okay, click next is click OK. Partition is created. Next is to create a FreeBSD swap. So here, unlike other operating system where the installation is a selection, you just select the type here, the type of operating system, the type of partition. Here you have the type. Okay, so FreeBSD minus swap. Okay, and then the size is calculated automatically. No mount point, no label. Just click OK. And then we change this one, we delete. So the partition will be available for the whole disk. So you can say, yeah, it's previously UFS. Mount point is /home. Okay, options, trim is active. Click OK, and then we are done for the partitioning. We can click finish and then commit, and then format the system will format the hard disk, and then checking the software that will be installed in our PC. Okay. Okay, it takes time, usually not long. Guys, if you have questions, and then please say something. Yeah, you can type questions in the group chat. Okay. Yeah, in our system, most likely we use Debian. Okay, why? Because yeah, some software is already designed for Debian or CentOS. Yeah, very like for example, we have hosting system, yeah, service, and then in this hosting service we use solution for example cPanel, and then cPanel do not have support for FreeBSD operating system. Yeah, so yeah, so if you use FreeBSD, it is assumed that you already know how to use it by yourself. Yeah. Okay, so yeah, it takes time, especially when we install ports and source. So ports mean ability to install software directly from the source. Yeah, that's ports. SRC here, it means that it is a software for kernel. Yeah, this is kernel, and this is ports. Okay, for package management. Okay, just wait. Any questions so far? Yeah, in the future, perhaps we can have a webinar that discuss um, running services with FreeBSD, for example. Okay, it's finished. It's asking for root password. Okay, type it again, password, and then we need to configure the networking. Yeah, because main benefit for FreeBSD is server. Okay, and then so it has to have a connectivity with the network. So we are using, there are three interfaces here. So we'll use the first one, VT-net 0. So we would like to use IPv4. Now the SCP. Let's just type the address. 251, right? It's subnet mask. /0. Default route. .1. We don't want IPv6. Search sample.com. DNS. Yeah, this one is crucial. Okay, and then continue. Region, Asia, Indonesia, Java, Sumatra, KWIB, and then check calendar. Is the date correct? Okay, time as well. Is time correct? Okay, and then we activate services. Yeah. So SSH, mouse D, NTP-D, or whatever. So perhaps we can activate the NTP. Power daemon. Okay, no need. So just continue. And then there are several options for hardening. Yeah, for security, like randomized PID instead of using it sequentially. Okay, nothing. Would you like to add users? Yeah, okay. You can add username. Ahmad. Full name. UID empty as default login group. Ahmad. Invite to other group. Yes. Wheel. Yeah. So wheel means if you are part of wheel group, it means that you can do switch to the super user. Okay. So I'm logging, well, I will log in as Ahmad, and then because I'm part of wheel, then I'm able to log in to root. Okay, and then as you can see for shell, FreeBSD is FreeBSD base provides C shell, P shell, and then Bourne shell. Remember, Bourne shell, not bash shell. Okay. This is Bourne shell. This is the home directory. Directory permission default, password base, yes, and the password no, and the password no. Okay, my own password. Okay, password again. Lock the account, no. Okay, yes. Add another user, no. And done, finished. So if you want to change something, you can click one of the menu. Or otherwise, if you think everything's okay, and then go to exit. Installation finish. Would you like to go to shell? No, I don't want. So now, so what are you going to do now? So reboot. Okay, so reboot. Oh yeah, I need to stop the CD. Yeah, otherwise it will load always from the CD. Okay, I need to stop. Okay, stop it. And then start the operating system, start the machine. Yeah, so here it is. This is the FreeBSD login page, not login page, the FreeBSD interface. Okay, let's see then. Okay, so as you can see, link is up, so you can ping something. Yeah, SSH is created, as you can see here, right? Yeah, so I can log in with my own account. Yeah, and then because I'm real, so I can do so password here, and then I become root. Okay, so I can ping Google. Okay, right, so that's nice. I can do perhaps trace route also available. Yeah, trace route to N8888. Yeah, so there's the trace route things. Okay, so next is, yeah, perhaps we can do FreeBSD. FreeBSD to update FreeBSD update. FreeBSD fetch and then install. So it's fetching or downloading. We call it fetch instead of download. So this is usually what you are doing after you install FreeBSD. So make sure that the base file is updated. So currently in my system, it's we have what is it? We have a base system installed. Okay. Let's see, fetching patches 100. Whoa, that's quite a lot. Yeah, now it's FreeBSD 13. Any update? Any questions so far? Applying patches? Yeah. No. Yeah, it takes time here to patch the FreeBSD. And normally it's okay. Okay, so says okay, press Q for quit. So we already fetched, and then now we apply the updates, installing the updates, and then done. Oh, that's fast. Try again. Just inspecting system. Yeah, as long as you have a good internet connectivity, you should be okay. See, no updates. Yeah, so usually when you do update, what happens is this one here will be a change. Okay, so previously it was P3, now it's P4, right? Or yeah, or newer. Or sometimes if you have a major upgrade, this one is changed. So it's similar to like Ubuntu or Debian upgrades, right? Yeah. So yeah, what about the package installation? we can use pkg, for example, install bash. Remember, bash is not part of FreeBSD based system. Oh, okay. So package management is not installed. You want to install it? Yes. Yeah. So FreeBSD will download the files from their own repository. Okay. Proceed. Yes. And done. Finish. As simple as that. So if we want to use bash, you can just type bash. Yeah, so we are bash now. Okay, exit. Or you can change it to basic. You can change it to etc password. Yeah, there. Yeah, over here. Yeah, here you can change that. Okay, so as you can see, if we check where the bash is, it's located in user local bin. Yeah. So for those third party executable will be placed on user local bin. What about shell, which bone shell? They are in bin sh. Also ls, for example. Yeah, or other files. Yeah. Okay, so I think that's all. Oh, it's almost 9 o'clock here. Any questions so far? If not, then I think it's time to take a photo for all of us, right? Yeah, I know. Yeah, FreeBSD here is. Yeah, there is a market for FreeBSD. Yes, instead of Linux. It has its own segment. Okay. So I don't think it's a bad idea to learn FreeBSD. So yeah. Any questions? No. So if not, then let's take a photo. Yeah, I'll count 1, 2, 3. Yeah, my experience with FreeBSD is I have clients. Normally we use Linux. Okay. Yeah, the FreeBSD community is relatively small compared to Linux. Okay. So not so many people learn or use FreeBSD all the time. Okay, so it's a very niche, very niche market here. But there are some people over there still use FreeBSD. Okay, so for you, yeah, for the job market, it is still promising. Okay. Oh, I have a question here. I'm new to learn this. What project I can do to learn more about the FreeBSD? Well, project. Well, you can build FreeBSD for. You can use FreeBSD to provide service. Usually, FreeBSD is used for providing service, right? Like you can set up a web server, whatever server, email server, DNS server, many servers. And then with the FreeBSDs, most of the software are installed from source. Yeah. So when you run, they will give you a better performance. Okay, so time to take a picture. Okay, please turn on your camera, guys, please. Right. Okay, thumbs up. 1, 2, and 3. Yeah. Okay, one more. 1, 2, and 3. Yeah. Well, in the future, perhaps we'll. Oh, okay. So we have another person here. 1, 2, and 3. Yeah. Yeah. So in the future, I think we can schedule uh, a webinar for discussing more details about FreeBSD. Right. So guys, thank you very much for your attention. All right. So thank you very much. And then please submit your feedback.